Namaskar everyone, my name is Dipendra and I welcome you all in this session where we'll be discussing quadratic expressions. Yes, I welcome you all in the bridge course where we are trying to merge or figure out the gap which is there or trying to bridge the gap which is there in your preparation. I hope you do remember that. Just hold on for a while. Okay, Victor, just give me a quick confirmation. Am I clearly audible now? Am I clearly audible? Everyone, just give me a quick update. So can you all hear me properly? Can you all see me properly? The screen right there in front of you. I hope it's properly visible and audible to all the participants. And with that, yes, I got a confirmation. Let's get started. I repeat my part that we welcome you all in this bridge course where we are trying to bridge the gap which got created between your 11th and 12th. So if you are moving from 11th to 12th and if you want your preparation to be more focused, hi, hello, hi everyone, good to have you all. If you want your preparation to be more focused, then here we are trying to create that merger point here so that all the topics or most of the crucial topics, the important topics which you have studied in 11th, which you may have or may have possibly missed, those points or those topics or those chapters will be covering here in this bridge course. Without any ado, let's get started. Today we'll be discussing quadratic expressions which are not only used in quadratic equations but also used in integration, calculus, even in sequence and series, even with some other chapters, even in sometimes in trigo or a lot many times. So yes, this chapter has its own significance, its own value, which comes with a lot of learnings, which we'll be exploring here. And yes, JEE.
Hello, hi, namaskar everyone. Just give me a quick update. Am I clearly audible and visible, students? I hope I'm clearly audible and visible to all the participants. And here we can get started with the discussion right now. I hope you all are there, listening, watching, and understanding. So I think it's going great, 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 great. So I hope sound is clear. I am clearly visible. The screen is properly visible to all the participants, and we can get started with our discussion now. Just give me a quick update, participants. Is it clearly visible, and am I clearly audible to everyone? Let's get started with this. Sir, you're audible and visible. Thank you so much, Victor, for that confirmation. Okay, so let's get started. I repeat this part that here we'll be discussing quadratic expressions where we are trying to bridge the gap between 11th and 12th standards. So if you are moving into 12th from 11th, great. From 11th, then of course, few things which you should, of course, consolidate. And if they get missed, you face problems in your 12th standard. That's exactly what we'll be covering in this particular video. So without any delay, let's get started. Here we are. First of all, we'll be exploring identities. We'll talk about identities, standard quadratic equations. We'll talk about roots, its nature, and then we'll talk about roots and coefficients. Then something really important, we'll talk about Newton's formula as well. So majorly, this is all what we'll be covering. Without any delay, let's get started. And first of all, let's get clarity on what is an identity. For example, if I write, let's say, an expression, for example, here, x plus 1 whole square, which of course is going to be x square plus, let's say, 2x plus 1. Now, please pay attention. This is simply an identity. What does it mean? Identity means that this will be true for all the values of x. It means that it does not have a solution. It has, if you talk about its solutions, then it has all the real values as its solution. I repeat, if it is not an equation, if it is said to be an identity, that means this will be true for all the real values of x, which means whatever real value of x you got to try on left hand side and on the right hand side, you'll get the same expression. You can try any value. Let's say I try x as 5. 5 plus 1, that's 6. 6 square is 36. If I try 5 here, 5 square is 25. 5 into 2 is 10 plus 1. That is again nothing but 36, which means 5 is not a root of this equation. First of all, please understand this is an identity. I hope first of all you are able to understand the meaning of the word identity. So here if somebody says that it is an identity, the coefficients on the right hand side and the left hand side of the same degree term are equal. What did I say? I'll try to say it in different mode or in different sense that here if I take, let's say if I take all the terms on the left hand side, let's say. So on the left hand side, I'm having an expression. On the right hand side, I'm having a 0. And I'm told that this is not an equation, this is an identity. So if somebody says that this is an identity, well, that can be true if the coefficients of the terms here, x square, x and constant, if they all are 0. Are you understanding my words? I hope you are getting it more clearly. Let me try and come up with this conclusion in a more better manner with an example. Pay attention to this part where, first of all, remember, whenever somebody says that this expression over here, let's say, is said to be an identity. Or in different word, let's say in the question, it is written that this is an nth degree polynomial, which is equal to 0. So we may treat it as an nth degree equation. So if it is an equation of nth degree, it can have maximum how many roots? The maximum number of roots it can have will be n. So the maximum number of real roots it can have will be n. Sir, quadratic is 11th chapter. Are you revising 11th? Yes, we are revising the important portion of 11th which you will need or require in 12th. That's why we are revising or studying it in this bridge course. Now, possibly not, possibly not. We'll do it in the Arjuna batch. So here if I talk about the maximum number of roots here, the maximum number of real roots or total roots, it can have n. But if somebody says that this is a polynomial of degree n which has more than n roots, are you listening to the word? If this is a polynomial of degree n which has more than n roots, then I think there is something wrong with this equation, or I'll rather treat it as an identity. I repeat my part very clearly. If there is an equation, let's say ax square plus bx plus c is equal to 0. So technically we know that whether complex or real, it can have total and maximum 2 roots. Now, if somebody says that this quadratic is satisfied by 3 values alpha, beta and gamma, mathematically speaking, for an equation, this is not possible. We all know that. But if somebody claims that yes, 3 values alpha, beta and gamma satisfy it, in that case, please remember that can happen only when this is not an equation, rather this is an identity. First of all, are you understanding the meaning of the word identity? Yes, yes, yes. Even distinct or repeated, if simply it has more than n roots, then it will be called an identity instead an equation. Are we clear on this? I repeat my part more clearly. And if that is true, which means what? LHS is equal to RHS. So for any value of x, this is 0. I repeat my line. For any value of x, this is 0. Which means x does not impact it. X does not affect it. So if this equation is always 0 for any value of x, which means it is independent of x. Which means whatever value of x I put here, this will always be 0. So how can I ensure that the LHS is always 0 irrespective of any value of x? I hope you are getting my point. Sir, that can happen only when A, B and C are 0. So if it is an identity, as I have already mentioned and said, that the coefficients in the constant term should be 0. Did you digest it? Are you able to comprehend it? Are you understanding what I'm trying to convey here, or what is the meaning of an identity? In a simple world, if I say that here, if we have sine squared theta plus cos squared theta, remember this, even this is also an identity. This is not an equation where theta has a solution. Let's say if you say, sir, theta when I put 30 degree, it gives you 1. No, it will give you 1 for any real value of theta. You try any real value of theta, it will always give you 1. So it is independent of theta, which means what? Here, this is again an identity. I repeat, this is an identity. Identity means here it will have more than the roots, which means here it is satisfied by all the real values of theta, which means it is not even dependent on theta, rather it will always be 1. This is a fact, this is a truth, which means I hope you must have seen in the last slide here, if I talk about this expression, I hope you all know it very clearly that sir, x plus 1 whole square minus whole of x square plus 2x plus 1, irrespective of any value of x, this will always result into 0. Give me a quick confirmation in the chat box. Did you all understand this? Did you all get this? Can we move ahead from here? Now, if you have understood the concept of identity, let me take you through one more example or one more interpretation of identity. What does it mean? Here, pay attention to this part, students. Let's say this is an equation, which is a pentic equation, degree 5, which is equal to another pentic equation or expression. So a pentic polynomial is equal to another pentic polynomial. But let's say in the question it is stated that, sir, it is not an equation, it is an identity. It is not an equation, rather it is an identity. So how can it be true? When do you say that this is an identity? I'll simply say that, sir, if it is an identity, then the coefficient of the same degree term, I'm really sorry, this is not a pentic, this is a biquadratic. So coefficient of the same degree term will be same, which means A here will be 5, B here will be minus 3, C here will be plus 4, D here will be minus 7, and E of course will be minus 9 undoubtedly. Are you able to digest this part, all the participants? Not just that, sometimes you got to do this as well. What? You take all of this here on the left hand side, so it will become a minus 5 times x to the power 4. Then it becomes plus b minus minus 3, that is b plus 3 times x cube. Then it's c minus 4 times x square. Then the term with x d plus 7 times x, and then the constant term. What is that? So the constant term is e plus 9. The constant term is e plus 9. And if this is set to be 0 for all the real values of x, which means it is not an equation. If it is a biquadratic equation, then it must have 4 roots. But if it is said that it has more than 4 roots, which means if it is true for all the real values of x, sir, that can happen only when LHS is 0 for any value of x. Yes. How or when can it be true? So this can be true only when the coefficients become 0. So this and this becomes 0, then it doesn't matter whatever value of x we put, it will always give me 0, which means what? A minus 5 becomes 0, which means A becomes 5. B plus 3 becomes 0, which means B becomes minus 3. C minus 4 becomes 0, which means C becomes 4. D plus 7 becomes 0, which means D becomes minus 7, and E plus 9 becomes 0, which means E becomes minus 9. Did you all understand that? All the participants, give me a quick confirmation in the chat box. Everybody with me on this? Can I move ahead from here? On this part, are we clear on this? Now from here, these are some standard identities which you got to remember. These are some really straightforward ones which you simply cannot afford to miss even in 12th standard. These are the ones which are used amazingly almost everywhere or anywhere. So in the questions of, let's say, integration, limits sometimes, differential equations, or maybe somewhere else, you will see these identities getting used. So let's go through them one after another and let's see what do they mean. I hope you can see all those identities right there in front of you on the screen. Everybody can see them. So here we are. Let's start discussing them. The first one, the straightforward one. A cube plus B cube. I hope we know A plus B times A square minus AB plus B square. And if it is A cube minus B cube, it is A minus B, A square plus AB plus B square. How I personally remember it, please remember this logic. I have always used this logic a lot many times. If there is plus, so this sign and this sign always remains same. What does it mean? Just hold on for a while. There is something here with the AC. Let me just get it fixed here. Hold on for a while, students. So what I was saying is that this sign and this sign will always be same, and this sign and this sign will always be opposite. And remember, the sign before a square and b square is always positive. It is always positive. I said 3 things. Did you listen to them? The first part. If it is plus, this will be plus, this will be minus. If it is minus, this will be minus, this will be plus. And a square and b square are always positive. That's what I said. Remember it, it is used at a lot of places. If I talk about the next identity, it is simply this straightforward one. A cube plus B cube plus C cube minus 3ABC is A plus B plus C times whole of A square plus B square plus C square minus AB minus BC minus CA. Now, why are we discussing this one? Again, a lot of questions are framed based on this. When and how, let's have a look at that. If let's say sometimes I am told in a question that there are 3 numbers which have their sum as 0. So A plus B plus C is given as 0. Always remember, if A plus B plus C becomes 0, 0 into anything becomes 0, which means this LHS is equal to 0, which means always remember A cube plus B cube plus C cube minus 3ABC will be 0, which means what? A cube plus B cube plus C cube will be equal to 3ABC. No, 1 by 2 is not multiplied. 1 by 2 Sudarshan is multiplied when you do one thing. Which thing? Let me help you with that. This identity is absolutely correct. But if you want to have that other identity which you are trying to talk about in the comment, I'll say, let's say if I'm given A cube plus B cube plus C cube minus 3abc, which is definitely a plus b plus c whole times a square plus b square plus c square minus AB minus BC minus CA. This is the correct version of it. But what the version which you're wanting is simply, let's say if I multiply and divide it by 2. So let's say if I do a 2 by 2 here, I hope that's absolutely doable. Yes, Parnika, I'll teach from basics. Why would I not teach from basics? Even the first chapter in the Arjuna and Laksh, Arjuna is clearly this basics of maths. And even in Laksh, will start from scratch. We know that. Right. Now, if I get back to this discussion, half of a plus b plus c, and now when this 2 is pushed inside, it makes it 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca, right? Now with that, what do we get? I hope we can clearly see that here there is something really interesting happening with this half of a plus b plus c remains intact. What do I have? If I take 1a square from here, 1b square from here, and this minus 2ab, a square plus b square minus 2ab, that gives you a minus b whole square. Then similarly, 1b square, 1c square minus 2bc, that gives you b minus c whole square. And with that c square and a square with this minus 2ca, that gives you c minus a whole square. So I think, Sudarshan, this is exactly what you were asking for. So this is that version which you are asking for. Am I clear on this, everybody? So this is another version of this identity. Let's get back to the discussion we were having here. Another version is this, we all know, this I think we all know, that x square plus y square plus z square plus 2xy plus 2yz plus 2zx is nothing but x plus y plus z whole square. Now this is a very interesting version, x to the power 4 plus x square plus 1. Again, there are a lot of questions formed on this x to the power 4 plus x square plus 1. Trust me, trust me, trust me. Even in sequence and series, when they use telescoping sum or even VN method, or sometimes in integration, they cancel out the terms, or even in definite integration, or even in differential equations, we have seen in January and April shift of this year as well, they have very vividly used this particular identity. Pay attention to this one. This is an amazing one, which is very meticulously used in a lot of questions. If it is given as x to the power 4 plus x square plus 1, you should remember the direct result. But yes, I'll tell you how is it formed. So here, let's say, if I write it in different form, x to the power 4, I'm writing as x square whole raised to the power 2. This x square, I'm writing as 2x square, which of course I cannot do. But in maths, we have this liberty to equate, to balance it out. So if I have written it as 2x square, I'm subtracting x square so that it remains balanced. Everybody with me on this, all the participants. Now from here, what I do next is, I hope you are paying attention to this part. This is a square plus b square plus 2ab. So this becomes a plus b whole square, and this is your x square. Now pay attention to this part, it is even more interesting. A square minus b square, that's a plus b into a minus b. So can I not say that, sir, in this case, it will be a plus b into a minus b. So a plus b is what? X square plus x plus 1, and a minus is what? X square minus x plus 1. Give me a quick confirmation on that. Everybody got this? So this is again a very crucial identity which JEE keeps on asking repeatedly. Trust me, repeatedly. So remember this. Don't forget this. On this, they have been asking a lot of questions lately. Don't forget this. I hope you will remember this. You wouldn't forget this. With that, the next one, of course, this is again a standard result, which means no. Today it wouldn't start. It will start later. We have postponed the launch of Arjuna. Right now we are focusing on Laksh, but very soon we'll be launching Laksh as well. Sorry. Right now we are launching Laksh on 20th, and very soon we'll be launching the Arjuna as well. Right? I hope I have answered your query, Mishal. Now with that, yes. With that, let's talk about this result as well, which is again a very crucial one. Remember this as a result, that x to the power n minus y to the power n upon x minus y. I repeat, this is how you should remember it. X to the power n minus y to the power n upon x minus y. This is always equal to x to the power n minus 1 plus x to the power n minus 2 into y to the power 1 plus x to the power n minus 3 y to the power 2, and so on and so on. Now, what is the catch here? Yes. IOQ. I don't remember what is IOQ. Now, if I get back to the discussion we were having, all I'm trying to say is that x to the power n minus y to the power n is always divisible by x minus y, and this gives you this as a quotient for any natural number n. I repeat my part very clearly, that if x to the power n minus y to the power n is divided by x minus y, where n is any natural number, then the remainder is always 0, which means this is always divisible by this. Will you remember that? But there is again a catch, a simple catch here, that let's say if there is x to the power n plus y to the power n, if it is needed to be divided by x plus y. So instead of minus, there is plus. Now in this case, the remainder will be 0. The remainder here will be 0 only when this n is an odd number. Please remember these basics. They are very widely used, not only in binomial theorem, but at a lot of other places as well. Yes. Definitely. No. It will not start after 7 p.m. It will be there in the evening, possibly in the evening, right? Now, when I talk about few more identities, these are few more, as I think most of them we have already discussed. This one, I think, Sudarshan was asking for, right? So I think we have covered mostly all. Can we get started or move ahead with this? I hope this one also, you know very clearly that x plus y plus z whole raised to the power 3 is always x cube, y cube, z cube, the summation of them, then 3 times whole of x plus y plus z, and z plus x. Will you remember that? Can we directly move towards the next question here? Now pay attention to this question, again an interesting one. I'll ask you to solve it by yourself. Take 2 minutes time. Do it by yourself and then we'll discuss this question together. Read the language and you will be amazed at how beautiful this question is and how can you solve it within seconds. Pay attention to this part. They say this equation is satisfied by more than 2 values of x. What are you interpreting by this? Are you not learning that, sir, in this question? If it is being a quadratic in x is satisfied by more than 2 values of x, then definitely quadratic has 2 roots. But if it is a quadratic which has more than 2 roots, sir, I think there is something wrong with this question. Instead of calling it an equation, this is definitely going to be an, I hope you are understanding, this is definitely going to be an, I hope you are understanding, identity. So rather than telling you that it is an identity directly, they have given it like this in this language. Everybody got this, all the participants. Have you tried solving this by yourself? Now, if it is an identity, do you remember that, sir, here on the LHS I'm seeing a quadratic, on the right hand side it is 0. Sir, it is an identity only when the coefficient this and this becomes 0. So first of all, if this coefficient becomes 0, lambda square minus 5 lambda plus 6 should be 0. And means this and this should also be 0, which means lambda square minus 3 lambda plus 2 should be 0. And this result, which is lambda square minus 4, this should also be 0. Everybody getting that? That's brilliant. Now somebody is saying, I think it's Akaf. I totally get this. Akaf. For this, you need to talk to our management team. I think they'll resolve your query. Right. Now, when I move ahead with this, I hope you're clearly understanding this is lambda square minus 2 lambda minus 3 lambda plus 6, splitting the middle term. So 2 and 3 are the two values of lambda which we are receiving from here. Everybody getting that? If I solve this one, I hope splitting the middle term, lambda square minus 2 lambda minus lambda plus 2. With that, we get two results, lambda as 1 comma 2. Now this is clearly a square minus b square. So if lambda square is 4, we clearly see lambda to be plus minus 2. So we get two values of lambda, which is minus 2 and plus 2. But I hope you are understanding. Definitely. What I need to do is I need to take the intersection, because here I need to ensure that I take a value of lambda so that this and this and this, all three of them become 0, which is happening with the intersection. I think 2 is there, 2 is here as well, and 2 is here as well. So 2 is that common value which is there for all these equations, where if I put lambda as 2, all of them will simultaneously become 0. Otherwise not. If I put 3 here, this becomes 0, but they don't. If I put 1 here, this becomes 0, but they don't. If I put minus 2 here, these two don't become 0, which means the common value among them will be 2. So here, the answer would have been lambda as 2. So if lambda is 2, this will be an identity instead of an equation. That's good, students. I'm glad some of you could crack it. Brilliant. That's perfect. What about the other participants? Have you all understood this? Can we move ahead from here? Everybody. With that, when we talk about this next result, let's talk about the standard quadratic equation. So if I'm given an equation, the quadratic one, I hope you remember this, ax square plus bx plus c is equal to 0. Then we do know that here, first of all, this coefficient of x should never be 0. Because if the coefficient of x becomes 0, this will not be a quadratic, this will become a linear. And of course, a, b, c could be any complex real number, complex number I'll say, because we are talking about complex quadratic equation. So even not just for the real quadratic equation where the coefficients are real, even the coefficients are complex, then also we apply this Sridhar Acharya formula that its roots are given by minus b plus minus root d by 2a. But of course, if it is a complex quadratic equation, then nature of roots does not get decided by root d only. But if it is a real quadratic equation, which means the coefficients here are real, then the nature of the roots gets decided with the help of this t. Are you listening and understanding this? We have studied in 10th standard where we all know this d is nothing but the discriminant which is given by b square minus 4ac, and that decides a lot of things. I hope you do remember that, sir, if this is greater than equal to 0, then you have real and distinct roots. I hope you do remember that. If it is equal to 0, then still you have real but equal roots. I hope you do remember that. But if it is less than 0, in that case, we have imaginary, rather the complex, and unequal, again distinct roots. Because if it is complex, then I'll get conjugate roots. Conjugate means if one of the roots is p plus iota q, then other root definitely be p minus iota q. But this is true if this quadratic is a real quadratic. If this quadratic is a real quadratic, which means here if a, b, c are real number. Remember this, if this is a complex quadratic, let's say if this is a complex quadratic where coefficients are complex numbers, and let's say one of the roots is p plus iota q, then you just cannot say that the other root will be p minus iota q. No, that doesn't happen. Are you listening and understanding? Again, there is a catch. Students commit a mistake here that let's say there is a quadratic, let's say ax square plus bx plus c is equal to 0. Let's say one of its roots is, let's say, of this form, p plus root q. Then some student says that the other root will be p minus root q because they are conjugate. If the roots are irrational terms, then if one of the roots is p plus root q, other root is p minus root q. No, absolutely wrong. Again wrong. This happens only when a, b, c are rational numbers. I repeat, if a, b, c are irrational, then it is not necessarily true that roots, if there are roots which are irrational, they'll exist in terms of conjugate pairs. Are you getting my words? What we usually do is, let's say in a question, if I'm said that one of the roots of the quadratic is 2 plus root 3, then we conventionally take the other root as 2 minus root 3. You definitely can. But for that, you need to ensure that the coefficients here are rational. If the coefficients are said to be or given to be irrational, then again, this assumption is wrong. This is absolutely wrong. Are you understanding all what I'm saying, students, everybody? With that, if I move ahead with few more conclusions, let's solve one question from JEE Mains 2025. Anybody who's willing to answer this question, again, I'm giving you 2 minutes time. Try it by yourself, by the way. Meanwhile, I'll also keep trying it. And once I reach to the conclusion, you tell me whether you have gotten the answer before me or not. I'll be really happy if you could solve this question before me. So I think this much was sufficient time to interpret this or to grasp this here. The number of solutions of this equation. So number of solutions. Now, when you start solving this, one of the methods is that you multiply it by root x on both the sides. I think it will unnecessarily complicate it. So what I'm suggesting here to do is that, sir, let's say for a while 1 by root x we take as t. What happens with that? So if I square it on both the sides, 1 by x becomes t square. With that, what is the advantage? For Arjuna, Swapnil, I'll say it will take some time, but probably in the month of May. In the month of May, we'll definitely be starting the Arjuna batch. Yes. Now, with that, when I go ahead with this conclusion, I hope you remember that 9 by x, that is clearly 90 square. This is 9 by root x. This is 90 plus 2. That's one of the factors. The other factor is 2t square minus 7t plus 3, and that is given as 0. So if I factorize this part, I hope you're understanding 9 into 2 is 18 and 6 into 3 is also 18. So I'll be writing it as 90 square minus 6t minus 3t plus 2. Everyone comfortable with whatever I'm doing here? Now this next part here, 3 into 2 is 6. So I think minus 6 and minus 1. So that gives you 2t square minus 6t minus t plus 3 is equal to 0. So I'll factorize this, I'll get 4 values of t. So if I start solving those values of t, don't say there will be 4 solutions and don't mark 4 is the correct answer, because that is the value of t and t is nothing but 1 by root x. What if you get the value of t as negative? So if this is negative, 1 by root x can never be negative. So that will be an unacceptable value. I hope you're understanding it. So there you got to delve deeper. Don't conclude that we are getting 4 values of t. That means 4 will be the answer. Don't conclude at this stage. Verify those 4 values are positive or not, because I hope you're understanding 1 by root x is there or non-negative or not. Even with that, this 1 by root x can never be 0. So it should be positive. So here, if I begin my discussion with this, first of all, one of the values here of t will be minus of minus 6 by 9. So that is plus 6 by 9. 6 by 9 is what? 2 by 3. The other value will be minus of minus 3 by 9, which is 3 by 9. 3 by 9 is, of course, 1 by 3. With that, if I talk about this, that's brilliant observation, Sudarshan. Yes, we need to have all the roots to be positive. The value of t should be positive. Minus of minus 6 by 2, that's 6 by 2. So that value we receive as 3. And here, minus of minus 1 by 2, that's 1 by 2. So we have received all the 4 values of t to be positive, which means 1 by root x is this, which means x will be an acceptable value for all these 4 values of t, which means yes, these all 4 values of t are acceptable. Based on these values of t, I'll get 4 values of x, which I need not explore, because here I am asked the number of solutions, which is going to be 4. Then you claim. Don't be in a rush that you state here that the number of solutions will be 4. You may have gone wrong. Everybody understood this logic, all the participants. Are you all getting this? Everybody understood this explanation. So I hope you're understanding. In JEE Mains, you solve 3 lines of questions as well. In JEE Mains, of course, there are 25 questions. But remember, there are always 10 to 12 questions which are easy. One question gives you plus 4 marks. 10 questions will give you 40 marks. So in math section, which is said to be tough, lengthy, there are 10 questions which are always doable if you know the basics. Remember that. 3 steps question it was. I hope you are understanding it. So yes, maths is always doable. Maths is easy. You just need to figure out the correct questions. You just need to select the right questions. That's the job you need to perform. With that, let's understand few more concepts. When you talk about nature of roots, what is the meaning of nature of roots? Let's say A, B, C are said to be some real numbers. Of course, where A is not 0, which means what? We are talking about the quadratic ax square plus bx plus c, right? This is the quadratic we are putting under consideration. I hope you remember when d is negative, what happens? When d is positive, what happens? And when d is 0, what happens? We have discussed it a lot many times. All I want you to remember is that, let's say, if you are given the quadratic as ax square plus bx plus c, and if its roots are x1 and x2, then don't take the equation as x minus x1 into x minus x2. That's again a problem. X into x will be x square, so it should have the coefficient a here introduced. Did you understand my language? So if you want to put this equal to this, there should be this a here. I hope you are understanding it more clearly, without any confusion. Similarly, if this has b as 0, the discriminant is 0, which means it will have equal and real roots, which means this part becomes 0. So the roots will be minus b by 2a. So if that is the root, alpha and beta or x1 and x2 both are minus b by 2a, then yes, we remember that this quadratic ax square plus bx plus c will not be written as x minus x1 whole square. No, it will still have this a. These are some simple mistakes which students commit. They don't take care of these minute details. They are not aware of these nuances, and that's where they go absolutely wrong. And that's where they don't get the correct answer. And yes, in the options, you will be given that option as well, which you will get by not taking this A. They know you make these mistakes, and they'll put those options so that you confidently mark that and move ahead with the confidence that yes, you have done it right. But they know that you may solve it incorrectly. Are you getting my point here clearly, all the participants? With that, let's talk about few more things. I hope you do remember. Let's say there are two quadratics. And those quadratics have their discriminants as d1 and d2. So there are two quadratics. Let's say first quadratic is a1x square plus b1x plus c1. The second quadratic is a2x square plus b2x plus c2. Of course, let's say this has the discriminant as d1, this has the discriminant as d2. This quadratic has roots, let's say alpha and beta, this has roots gamma and delta. I'm not saying alpha and beta are real, imaginary, or whatever, but I'm saying that these are the four roots of these two equations. Now pay attention to this part. Let's say if somebody says d1 plus d2 is non-negative, d1 plus d2 is greater than equal to 0. Now you tell me, when can it happen? Sir, if sum of two numbers is positive, then at least one of them is positive. I hope you are understanding. If this sum d1 plus d2 is greater than equal to 0, that happens only when either both are positive or at least one of them is positive. Because if both of them are positive, then the sum will be positive. If at least one of them is positive, then that positive minus negative could be positive, because that positive will be greater in magnitude. The third conclusion, if both are equal in magnitude but opposite in sign, then also it will be 0. So we are talking about that possibility only when you have this d1 plus d2 greater than equal to 0. What does it mean? It means one of them is definitely going to be positive. Which means if one of them is definitely going to be positive, which means what? That at least one of these quadratics will have real roots. Shall I repeat this part? I repeat this part. If at least d1 or d2 is positive, or both of them are positive, so if at least one of them is positive, and exactly one of them is positive, then either this could have real roots or this could have real roots. Or if both of them are positive, that's the best thing, because this will be real and this will also be real. So did you understand my statement, all the participants? Let's talk about the next conclusion. If somebody says that d1 plus d2 is negative, if somebody says that d1 plus d2 is negative, what does it mean? Sum of two numbers is negative. Sir, when can that happen? Sir, this can happen when both of them are negative, or exactly one of them is negative and it is greater in magnitude than the other. Are you understanding my words very clearly? Which means what here? Let's say if at least one of them is negative, which means either exactly one of them is negative or both of them are negative. So if exactly one of them is negative, which means either these are imaginary roots or these are imaginary roots, or if both of them, d1 and d2, both of them are negative, then this and this both are imaginary. So are you able to digest what can we interpret if, let's say, two quadratics, discriminants, sum is given as either positive or negative, or as either non-negative and negative? Then what can we conclude based on that? Are you understanding that? Will you remember that? Direct questions are asked based on this observation, and if you do remember it, you'll apply it directly and get the answer very quickly in the examination hall. All the participants understood that. Can I move ahead from here? Now, this is something very crucial which I was constantly talking about. The first result. If A, B, C all are rational numbers, Q means what? The set of rational numbers. So if in this quadratic, which we have been constantly discussing, ax squared plus bx plus c is equal to 0, if this quadratic has coefficients a, b, and c, and if this a, b, and c are rational numbers, where if somebody says that d means what? B square minus 4ac, where I hope you do remember the roots alpha and beta, are given by minus b plus minus under root over d by 2a. I hope you do remember all of these conclusions. They are there in your mind, right? With that, do remember this conclusion that here, please remember this conclusion here, that if somebody says that d is a perfect square, if in a quadratic, if all of the coefficients are rational and d is a perfect square of a rational number, then please remember the roots are going to be rational, and if it is not a perfect square, then roots are irrational. Because see, if d is, let's say, 36, then root 36 will be 6. So minus b plus minus 6 upon 2a. So b and a are simply rational. So rational plus minus rational upon rational will be a rational number. There is no scope of it being irrational. But if this d is not a perfect square, then of course this root d will get introduced. It will make it irrational. Of course, the roots will be irrational. Did you all get that? Now, when irrational roots come into picture, that's exactly what I want to discuss. That if ABC, this part, if ABC are rational numbers and one of the roots is p plus root q, then other root you can blindly take as p minus root q. But mind this part, students, that A, B, C all should be rational. All of them should be rational. If it is not given, then you cannot take it like this, that one of the roots will be p plus root q and other root will be p minus root q. Are you getting that conclusion, all the participants? Everybody with me on this? Can I move ahead from here? Now the second part, if the roots are imaginary, which means if a, b, c are real numbers, remember again, I'm not saying a, b, c are complex numbers. If a, b, c are real numbers, and then if one of the roots is p plus iota q, where q is not 0 of course, then the other root will definitely be p minus iota q. Even the imaginary roots exist in pair, conjugate wise pair, and of course remember this, that in that case the coefficients a, b, c should be real. They should not be complex numbers, they should be real numbers. Are you digesting all of this? And we do remember it, right? If the sum of the coefficients is 0, then always remember this, that one of the roots is 1. One of the roots is always 1, and even other root can also be found. Let's say if one of the roots, because here x is replaced by 1, which means a plus b plus c is 0. So if a plus b plus c is 0, which means what? One of the roots is 1. So if one of the roots is 1, we know the product of the roots is c upon a. But if one of the roots is 1, the other root will be c upon a, because alpha is 1. So in that case, if one of the roots is 1, the other root will be c upon a. And when do you see one of the roots to be 1? If a plus b plus c is given as 0. Everybody understood that part comfortably, all the participants. Now when I move ahead from here, let's talk about few more things. You know, what is the sum of the roots? Minus b upon a. What is the product of the roots? C upon a. And what is the difference of the roots? Which means modulus of alpha minus beta, that is under root d upon mod a. How do we work it out? I hope you do remember this result as well. I hope you do remember it very clearly, that alpha minus beta whole square can be given by alpha plus beta whole square minus 4 alpha beta, because it will be alpha square plus beta square plus 2 alpha beta minus 4 alpha beta. So it makes it minus 2 alpha beta, which is the expansion of this only. Why are we discussing this? Because here, if I say alpha minus beta whole square, so alpha plus beta is what? Minus b upon a, but its square will be b square upon a square. Everybody getting that? This is 4 alpha beta c upon a, so it is 4c upon a. What I do is I multiply and divide this 4c by a, so it will be 4 ac by a square. Why did I do it? So that we can take the LCM. So with that, I have b square minus 4ac by a square on the right hand side, which is nothing but what? Alpha minus beta whole square. So if I wish to have alpha minus beta, because in terms of magnitude, I can figure it out. Because if I take this square root other, I'm supposed to put a plus minus over here. I'm taking the difference in terms of magnitude. Difference, greater minus lesser. That's what I'm doing. So that is given by root d, because under root over b square minus 4ac is what? Root d, divided by under root over a square. I hope you remember, under root over a square is not a, under root over a square is modulus of a. So do remember this as the result, that if you are given modulus of alpha minus beta, then it is always taken as under root d upon mod a. Are we clear on this? All the participants. Now with that, when we talk about few more conclusions, these are some more identities. I'll simply suggest you to remember them. Few of these I can definitely explain, but I'll always say that you derive them in the real examination hall instead of learning or memorizing them. At least these four you can directly understand by observation only. When we talk about alpha square plus beta square, as we have just discussed in the last slide, it is alpha plus beta whole square minus 2 alpha beta. It is self-explanatory, I think. With that, if I am dealing with this, I think I'll be writing it as this. This will be minus b upon a. This is under root d upon mod a. Depends, whichever is greater. If mod is not given, then I'll say plus minus root d by a, of course. Here, alpha cube minus beta cube. Why are we writing it like this? So that we can convert it into sum or difference or product of the roots. Similarly, this one, and this one. I hope you are comfortable with this. This part is self-explanatory as far as higher powers of roots and their sum or difference is asked. Then we'll use these identities. Everybody with me on this? Can I move ahead from here? Just give me a comment in the chat box if you want an explanation for this. I'll definitely explain any of these so that you get more clarity. But I think this part is self-explanatory because we know alpha minus beta whole cube is what? I hope you do remember. It is clearly alpha cube minus beta cube minus 3 alpha beta times alpha minus beta. So that's exactly what we have rearranged. Can you not see that? I hope you're getting it more clearly. With that, when I move ahead with few more conclusions, I hope you do remember quadratic graph when we draw, this is always going to be a parabola. This is always going to be a parabola. Now it depends on two parameters. Either the coefficient of x square is positive or the coefficient of x square is negative. I hope you do remember this. So if the coefficient of x square is positive, it will be an upward facing parabola. And if the coefficient of x square is negative, it will be a downward facing parabola. And always remember, if the coefficient of x square is positive, it will be having a minima. And that minimum value you will always attain at minus b by 2a. And that minimum value will be minus d by 4a. Similarly, if the coefficient of x square is negative, it will be a downward facing parabola. In that case, you will be having a maxima, and that maxima you will attain at minus b by 2a, and that maximum value will be minus d by 4a. Now, how do we prove this result? That result is a simple one, a straightforward one. That simply is given by this, that if you convert it into a perfect square. Now, what is the meaning of converting it into a perfect square? Y is equals to ax square plus bx plus c is what I'm given, where I clearly know that a is never 0, which means what? If I convert it into a perfect square, so y, if I take, let's say, a common for a while to make it more simpler, this will be x square plus b by a times x plus c by a. Comfortable with this result? If I take this a aside, x square is there, which I'm keeping as this only. This here, if I multiply it by 2, then 2 into x into b by 2 I am writing. So 2 and 2 are cancelled. I hope you're comfortable with that. So what am I doing here is a simple problem, that it is a square plus 2ab. So I need b square. B square means what? I need b by 2a whole square. So if I have added this, I got to subtract this, which means I got to subtract b square by 4a square from here. But it already has this c by a, so that needs to be kept there. Are you understanding how did I convert it into a perfect square? What am I doing here? I repeat, I hope you are understanding that this 2 and this 2 are cancelled. So this is xb by a. This and this are cancelled. So I'm left with c by a. So this equation is nothing but this only. But why did I do this? I hope all of you are noticing that from here to here, it is nothing but a square plus b square plus 2ab, which is a plus b whole square. So y will be given as a times a plus b whole square, which is x plus b by 2a whole square. Now, when I talk about this result, if I introduce a 4a here, so 4a, then it will be 4a square. So 4a square there, b square minus 4ac I can have here if I take the negative sign common here. So in the numerator, it will be d by what? 4a square. I hope there is no confusion on that. It will be b by 4a square, right? It is 4a square. Yes, it is 4a square. I hope there is no confusion on that part. Everybody with me on this? All the participants, just give me a quick update on this, everybody. Now, this is a quadratic expression, and its value, whether it will be attaining a maxima or minima, depends on a. Because if a is positive, this will be having minima. If a is negative, this will be having a maxima. Why am I saying so? Because here, this is clearly a parabola. This is clearly a parabola. You must have studied it in 11th. If I take this minus d by 4a square here with this a, here I'll be having this as y plus d by 4a on the left hand side, and on the right hand side it will be x plus, I'm already having this a here, so this is a times x plus b by 2a whole square. Now pay attention to this part. Is it not x square is equals to 4ay form? I hope you're understanding it. Now, it all depends on the value of a, because if a is positive, upward facing parabola, if a is negative, downward facing parabola. Are you getting some clarity on this part? And when you talk about its vertex, the vertex of the parabola, whether upward facing parabola or downward facing parabola, its vertex will be, I hope you remember, if I'm having this y minus k is equal to x minus h whole square. Of course, there will be some terms here as well. So its vertex will be h comma k. So that's exactly what I'm saying. Its vertex here will be minus b by 2a comma minus d by 4a. That's exactly what I was saying. So its vertex will always be minus b by 2a comma minus d by 4a. Either minima or maxima. Give me a quick update on this. Everybody understood this explanation? Are we clear on this, or shall I re-explain this part? All the participants. With that, when I talk about few more conclusions, these are some important results you got to keep with yourself. I hope this first result, whenever somebody says that x square is less than a square, simple result, a direct result. Let's say somebody says that x square is less than 9, which means x square is less than 3 square. Of course, you take it on the other side, then you use wavy curve. Don't do all that. Directly write the conclusion that x will always lie between minus 3 between minus 3 to 3. That's exactly what we are trying to say here through this identity. Not just that, we remember that x square and mod x behave similarly, which means what? Let's say if I'm given mod x is less than 3, then also we say the same thing, that x will lie between minus 3 to 3. So remember these conclusions, which we'll be using directly or indirectly or subtly at a lot of places. Similarly, let's say if I'm given one more conclusion where it says that x square is greater than 4. Again, you take it on the other side, you factorize it, and then you use wavy curve. I'll say, remember that x square is greater than 4, which means x square is greater than 2 square. Then always write this, that x square will be either less than minus 2, x will be either less than minus 2 or greater than 2. You can always conclude this. The same conclusion hold true for modulus as well. Let's say if somebody says that mod x is greater than 7. Mod x is greater than 7. Then you can always conclude that, sir, x will be either less than minus 7 or x will be greater than 7. Are you able to digest all what I'm saying, or shall I re-explain all of this? Give me a quick update in the comment box. If you need more confirmation or clarification, I'll definitely explain that part. Are we clear on whatever is said so far, all the participants? With that, let's move towards the next part. I think these conclusions we have discussed, I think this is something you got to remember, this particular one. This is again a very interesting one. What does it mean? Pay attention to this part. Let's say if I say that there's a number x, or let's say x square, which lies between, let's say, which lies between 4 to 9. So here, of course, I'll say x square lies between 2 square to what? 3 square. So if you are not comfortable with this direct result, you can solve this separately, and put an intersection between them. Or rather, again, I'll ask you to use a direct result. What is that direct result? The direct result says the simple thing that, sir, here x will lie between minus 3 to minus 2, between minus 3 to minus 2, and means union, or it is or 2 to 3. How is it getting derived? If you didn't understand this part, you can remember it like this as well. But I'll emphasize that you remember the direct result. But if you forget that direct result, you solve it like this. That's our x square is greater than equal to 2 square. And here, x square is less than equal to 3 square. Now, what does it mean? If it is given, then we know x will be either less than minus 2 or x will be either greater than 2. And intersection of this with this, that x will be from minus 3 to 3. I hope there is no confusion on that. Now, if I plot it on number scale so that we can find the intersection, of course, there is this number from minus 3 to 3. So it says that x lies between minus 3 to 3. That is this. Of course, you will have minus 2 somewhere here, 2 somewhere here. So this says that x will be either less than minus 2 or greater than 2. So if I take the intersection now, I hope you can see that intersection is clearly nothing but this portion. I hope you can see this portion is common to both of them, which means my final answer will be what? My final answer will be nothing but this only, that x lies between minus 3 to minus 2 or 2 to 3. Now, this conclusion you not derive with these steps every time. You can directly write this from here. That's exactly what we have mentioned over here through this identity, through this inequality. It has its one more modulus version as well. What is that modulus version? Let's say if I'm told that mod x lies between, let's say 7 to 10. Mod x lies between 7 to 10. Then remember, you can directly write the same conclusion that, sir, x will belong to all the values from minus 10 to 7 union, minus 10 to minus 7 union 7 to 10. Give me a quick confirmation in the chat box. Everybody understood this, or shall I re-explain this part? All of you are there, getting it clearly. With that, when I move ahead and talk about few more things, now we talk about Newton's formula, one of the most amazing formulae which JEE uses at a lot of places. A lot of questions every year in every shift are asked based on Newton's formula. JEE simply loves using this formula. Unfortunately, this year they haven't asked much questions based on Newton's formula, but definitely they are every year asking a lot of questions based on it. That's exactly what we'll be covering in this part. And of course, we'll be consolidating it with a lot of questions. Let's get started. First of all, remember, if you're given a quadratic, which of course is given by ax square plus bx plus c is equals to 0. And there is a term s and p and whatever they define is given as alpha to the power n plus beta to the power n, or alpha to the power n minus beta to the power n. Then always remember your quadratic, which was ax square plus bx plus c. this quadratic can also, this can also give you one more conclusion, that here this a remains as a, this x square I can replace by Sn or Sn plus 2, let's say, for a while. Then I'll have this b as it is. Then the coefficient of b is x to the power 1. So I'll be writing it as Sn plus 1. Then plus this c, the coefficient of c is x to the power 0. So I can write it as Sn plus 0, which is Sn. So this is how you can write this. What is the proof, sir? How can we do this? Please understand, a very simple, direct, straightforward proof is there. See, this will have two roots. Let's say those two roots are alpha and beta. So this will be satisfied by alpha and beta. So if it is satisfied by alpha and beta, then of course it will be a alpha square plus b alpha plus c is equal to 0. Similarly, it will be a beta square plus b beta plus c is equal to 0. Everybody got this? Now let's say I multiply this equation by a to the power alpha to the power n on both these sides. So it becomes what? A alpha to the power n plus 2 plus b alpha to the power n plus 1 plus c alpha to the power n is equals to 0. Similarly, this equation, if I multiply by beta to the power n on both sides, it becomes a beta to the power n plus 2 plus b beta to the power n plus 1 plus c beta to the power n is equal to 0. Now what I do next is I add this with this. I add both of these equations. So if I'm adding both of these equations, a and a is taken common. So you're left with alpha to the power n plus 2 plus beta to the power n plus 2. Then plus b and b is taken common. Then you're left with alpha to the power n plus 1 plus beta to the power n plus 1. Then c and c is taken common. There you are left with alpha to the power n plus beta to the power n is equal to 0. Now, are you not noticing that alpha to the power n plus 2 plus beta to the power n plus 2 is nothing but Sn plus 2? I hope you're getting it. So it will be a Sn plus 2, a Sn plus 2 plus b times alpha to the power n plus 1 plus beta to the power n plus 1 is nothing but what? Sn plus 1. So this will be Sn plus 1 plus c times alpha to the power n plus beta to the power n, that is nothing but what? Sn. So it will be c Sn, that is equal to 0. So that's exactly what I'm suggesting, that whether it is alpha to the power n plus beta to the power n or alpha to the power n minus beta to the power n, you can always directly substitute these results. We totally understand this, Purnika. Now let's focus in 12th. We'll definitely do it in such a manner that you don't have this regret anymore. I totally understand your concern. Everybody got this result. Everybody understood this result. Are we clear on this? Give me a quick update on this. Now, with that, if I try and give you more clarity about this Noodles formulas application through some questions, let's have a look at this question. By the time I'm having some water, you try and solve this, and then we'll discuss its solution together. Give it a try, everyone. Okay, so I believe some of you or most of you must have tried it. Let us discuss this question together. Here it says alpha and beta, where alpha is greater than beta. Perfect. Be the roots of this quadratic, where Pn, alpha to the power n, plus beta to the power n, alpha to the power n, minus beta to the power n. Now you have to remember. So instead of Sn, this is Pn, which is fine. N as a natural number, then this is what they are asking you. Let me simplify this. What do I mean by simplification? If I take P16 common, do you not think when you take P16 common in the numerator, you will be left with P15 minus P14? And here, let's say if I'm taking minus P15 common, let's say I'm taking minus P15 common, then I'll be left with P15 minus P14. Are you comfortable with this? And in the denominator, we have P13 into P14. In the denominator, we have P13 into P14. Of course, P15, P14 can be taken common. So here it will be P15 minus P14 into this is P16 minus P15 whole divided by P13 into P14. Now let's work on the quadratic we are given so that we may derive some conclusions here. This is x square minus x minus 4 is equals to 0, which has roots alpha and beta. Pn is given as alpha to the power n minus beta to the power n. Can I not directly write a result? What is that result? I can write it as 1 into Pn minus 1 into Pn minus 1 minus 4. I hope you do remember that, into Pn minus 2. I hope there is no confusion on that. With that, if I rearrange it, I hope you're understanding Pn minus 1 will be 4 times Pn minus 2. If I take this Pn minus 2 on the left hand side, I hope you're understanding Pn minus Pn minus 1 divided by Pn minus 2 will be nothing but 4. I think this expression gives you the final answer within seconds. Again, a question which you could have done in 3 seconds, in 10 seconds, in 3 steps, if you simply know the right logic. Where all I'm saying is that here, if I apply the right part, which means what? This part, pay attention to this part, P15 minus P14 by P13. So if I replace n by 15, 15, 14, 13, P15 minus P14 by P13, that's nothing but 4. So this whole expression is nothing but 4 into, look at this part, 16, 15, 14. So if I replace n by 16, P16 minus P14 by P13, I think, sorry, I'm really sorry. When you replace n by 16, so P16, P15, P14, that's exactly what we are having, P16, P15, P14, and that's nothing but again what, 4. So your answer will be 16. Was it not absolutely simple, easy, and doable? Everybody understood that? Or shall I re-explain this part? Give me a quick update and confirmation on this. Can we move ahead from here, all the participants? When I go ahead from here, let's solve one more question based on the Newton's formula. What does it say? It says alpha and beta are the roots of this equation, where Sn is 2023 alpha to the power n, 2024 beta to the power n. Now there is a catch. Sir, you have told it should be alpha to the power n plus beta to the power n, or alpha to the power n minus beta to the power n. But there is some problem. First of all, there is not a problem. If you have understood that derivation will help you in cracking the logic here in this question. How? I'll simply say that first of all, understand the question. If I make it satisfied by alpha, it will be alpha square minus alpha minus 1 is equals to 0. If I make it satisfied by beta, it will be beta square minus beta minus 1 is equals to 0. First of all, are we understanding this part? Everyone comfortable with this? Then we are asked something about this result. Let's talk about this result. I think I need to establish the relationship between S12, S11 and S10. So I simply need to establish the relationship between S10, S11 and S12. Right, I think I possibly can. First of all, let me get alpha to the power n. How? I'll simply multiply both the sides by, let's say, alpha to the power n minus 2. So with that, this becomes alpha to the power n. This becomes alpha to the power, of course, n minus 1. And this becomes alpha to the power n minus 2. I hope no confusion on that. And that's 0. Similarly, here if I multiply both the sides by beta to the power n minus 2, it will be beta to the power n minus beta to the power n minus 1. And that is minus beta to the power n minus 2, which is equal to 0. Everyone comfortable with what I have done so far? Now, I hope you're understanding what I'll do here is, to have something of that sort, I'll take these two terms on the other side, these two terms on the other side. So here I'll have alpha to the power n as alpha to the power n minus 1 plus alpha to the power n minus 2. Similarly here, beta to the power n will be this shifted there, which is beta to the power n minus 1 plus beta to the power n minus 2. Comfortable with this? Sir, we don't need this. We need alpha to the power n times 2023. Okay, so I'll multiply 2023 on both these sides. So it will be 2023 times alpha to the power n. Are you getting it? Which is 2023 times alpha to the power n minus 1 plus 2023 times alpha to the power n minus 2. Similarly, with beta to the power n, what I need is 2024. Okay, cool. So here, if I multiply 2024 on both the sides, it will be 2024 beta to the power n is equal to 2024 beta to the power n minus 1 plus 2024 beta to the power n minus 2. Everyone comfortable with whatever I've done so far? all the participants. Now if I add both of these equations, this plus this becomes what? 2023 alpha to the power n plus 2024 beta to the power n is equal to this plus this, which is again 2023 alpha to the power n minus 1 plus 2024 beta to the power n minus 1. This plus this is again 2023 alpha to the power n minus 2 plus 2024 beta to the power n minus 2. Give me a quick update on this. Everybody understood that part? Now here, if you are paying attention, club this with this, club this with this, and see this with this. Are you not noticing something very interesting here? Are you paying some attention here? I hope you are seeing this is nothing but what? This is your Sn. So this here on the left hand side, it is Sn is equal to, this is Sn minus 1. I hope you're noticing it. So this is Sn minus 1, and that I think is nothing but Sn minus 2. So that's your Sn minus 2. So I need to establish a relationship between 12, 11 and 10. So if I take n as 12, so S12 will be S11 plus S10. Are we given it somewhere? I think with option B. So that's your final answer. Everybody got this? Everybody understood this? Or shall I re-explain this part? Give me a quick update on this. Are you all there, listening, watching, and understanding, and comprehending very clearly? With that, let's solve one more question based on another part, or let's talk about location of roots. That is again something which is very widely used at a lot of places, which we'll be using here in 12th standard. Let's focus on that. What is it? Let me just refresh here. Okay, so moving ahead with this, I hope you're paying attention. If both of the roots of your fx, what is fx here? I hope you're understanding. Fx is always your quadratic ax square plus bx plus c. That's your quadratic. Of course, it is equal to 0, right? So if fx is equal to 0 means what? It means your quadratic ax square plus bx plus c is equal to 0. Now, we are told it's both the roots are less than k. So if they are compared with a real number k, which means they are real. So if I am told that both of the roots are less than k, when can it happen? So first of all, there could be this case where this is k, this is alpha, and this is beta. Or what else could have happened? So this is the case where this is k and both of these roots are alpha and beta. Or the third case, when this is the case where again this is alpha, this is beta, and this is k. Or the fourth case where both of them are alpha and beta equal roots, and this is k. Give me a quick update on this. I hope you have understood this part very clearly, that when you talk about a quadratic, these 6 cases are derived. Which 6 cases? Let me give you clarity about those 6 cases. Hold on for a while, students. Let me just talk about those 6 cases as well, so that when we talk about location of roots, you are more clear with whatever I'm saying here, right? So what are those 6 cases? I'll be drawing these curves. Which curves? Few times upward facing parabolas and few times downward facing parabolas. But what is the case here? What is the scenario here that plays a very major or a crucial role? Sometimes x-axis could be passing from here. Sometimes x-axis could be touching it like this, or sometimes x-axis would be somewhere below this. Absolutely not intersecting. Sometimes x-axis could be touching or intersecting like this. Sometimes x-axis could be touching it like this, or sometimes x-axis would be above this. Now this is all regard to that standard quadratic expression ax square plus bx plus c is equal to 0. Now, whenever it is an upward facing parabola, we all know that in that case, the coefficient of x square is always positive. Do you remember that? Whenever it is a downward facing parabola, we all know that in that case, the parabola is downward facing only when the coefficient of x square is negative. I hope you do remember that. Now, can you help me with few more cases? If it has two distinct real roots, if it is intersecting x-axis at two places, which means two distinct real roots. If it is touching the x-axis at one place, which means real roots, but both are equal. If it is not touching x-axis at all, which means imaginary roots. If it is intersecting x-axis at two places, two distinct real roots. If touching it x-axis at one place, of course, real but equal roots. And if it is not touching or intersecting at all, which means imaginary roots. Now, can you help me with the discriminant as well? I hope you remember. Two real roots means what? Discriminant positive. Equal in real root, discriminant 0. No real roots, discriminant is negative. I hope no confusion here. Discriminant is positive because two distinct real roots. Real and equal roots, which means discriminant is 0. No real root at all, discriminant is negative. If you have understanding of these 6 kinds of graphs, you will be more comfortable in solving this part when we talk about location of roots. Everybody getting this? Now let me get back to this conclusion. Let's say both the roots, it's not roots, it's roots. It's roots. So both of the roots are greater than k. I think previously we were talking about both of the roots less than k. I think this was the case. So it is again not roots, it's roots. So both of the roots are less than k. So first of all, both roots exist. So they may be distinct or equal. Again, quadratic's coefficient a could be positive or negative. So if it is positive, upward facing parabola. If it is negative, downward facing parabola. So these 4 cases will be there first of all. Are you getting it? Now, what am I told? That they are less than k. So k will be on the right of both alpha and beta. On the x-axis, k will be on the right of both alpha and beta. So what can I conclude? First of all, sir, since roots exist, they are real, which means d will be greater than or equal to 0. That's the first case. Second case, a dot f of k will be positive. What does it mean? Sir, look at this f of k. This f of k is positive. Look at this f of k. Again, this f of k is positive. But here, look at this f of k. This f of k is negative. Look at this f of k. This f of k is negative. I hope you are noticing something very important, sir. This is upward facing parabola A positive, upward facing parabola A positive, downward facing parabola A negative, downward facing parabola A negative. What does it all mean? It simply means that if it is upward facing parabola, which means if A is positive, f of k is also positive, which means A and f of k will have the same sign. If it is downward facing parabola, which means if A is negative, f of k is also negative, which means A and f of k have the same sign. If A and f of k have the same sign, their product will be positive. Were you able to digest this part, all the participants? The third condition which I will match is that, sir, this could have been true if k lies here as well. But I don't want k to be on this side, on the left of alpha and beta. I want k to be on the right of alpha and beta. That segregator can be introduced if I introduce one more point, exact middle of alpha and beta, which is the vertex, which is alpha plus beta by 2, which is nothing but minus b by 2a. So if k is greater than minus b by 2a, it is supposed to lie on the right of minus b by 2a. And if I'm saying that f of k is positive with a being positive, then this will be somewhere here only, not here. So if these 3 conditions are fulfilled, and if I take their intersection, I'll be ensuring that k is a number which is greater than alpha and beta, or both of the roots are less than k. Now, if I talk about the second case, when k is less than both of the roots, do you not think very simple result is needed to be brought into picture? What is that result? I hope you're getting it. Let's say either you will be having your curve like this or this, or you will be having your curve like either this or this. First of all, give me a quick update on this. Now, I hope you're understanding in this case. I hope in this case, I need not tell you a is greater than 0. Here, d is 0, d is positive. Here, in this case, I hope you're understanding a is negative, but in this case, d is 0, d is positive. So, first of all, d greater than or equal to 0 is needed. But again, what I want is, I want k to be less than both of the roots, which means k could be somewhere here. So, if this is k, I hope you're understanding f of k will be same as a. If understanding this is k, then we are clearly seeing f of k will be same as a, which means second conclusion is same, a dot f of k will be positive. But I hope you understand, in that case, k could be either here on the right hand side of alpha and beta or on the left hand side. So previously, in the previous case, when we wanted it to be right hand side, we told it should be greater than minus b by 2a. But this time we want k to be on the left hand side of alpha and beta. So the third condition which I'll impose is that k will be less than minus b by 2a, which is the midpoint, which is the separator which I'm using. So if I take the intersection of these 3 cases, I'll be having the number k less than both of the roots, or both of the roots greater than k. Did you digest this part? Are you comprehending what I'm saying? This part where I'm talking about location of roots. Now the third part, if k lies between the roots. Now what is the case here? I hope you're understanding. If both of the roots have a number between them, so I hope you're understanding. In this case, discriminant got to be greater than 0, because if discriminant is equal to 0, you cannot have both the roots to be distinct. If k is a number which lies between the roots, what does it mean? Do you not think that, sir, in this case, two possibilities are there? Either a is positive or a is negative, but in both the cases, discriminant has to be positive. Discriminant equal to 0 cannot be taken. But the third case, which I'll impose here, is this, that a dot f of k will be negative. Why? Because please understand, f of k, let's say k lies here, so f of k will be negative. But if, let's say, k lies here, in that case, f of k will be positive. So what are we concluding here? Are we not concluding a very basic phenomena, that here, if a is positive, f of k is negative? If a is negative, f of k is positive, which means what? A and f of k are of the opposite sign, which means their product will be negative. So these two conditions are always sufficient. If I wish to ensure that k lies between alpha and beta, or if I wish to say that alpha and beta contain a value k between them, then these two conditions I'll impose. I'll take their intersection, and that will be my final answer. Everybody got this? Can I move ahead from here? Now, when I solve the next part here, let's say exactly one root lies in the interval k1 to k2. What does it mean? Pay attention to this part. Now, again, exactly one means what? Discriminant cannot be equal to 0. It has to be greater than 0. So this is alpha, this is beta, where a is positive. Or the other case, when this is alpha, this is beta, where a is negative. Of course, in both of the cases, d is positive. Everybody listening can understand through that part. Now, I am given two numbers, k1 and k2. Let's say here, this is k1 and this is k2. Or let's say here, this is k1 and this is k2. I'm ensuring that alpha lies between k1 and k2. It is absolutely fine. All I'm saying is that if I find f of k1, it will be positive. If I find f of k2, it will be negative. Opposite. F of k1, if I find, it will be negative. F of k2, if I find, it will be positive. Again, opposite. So if I find f of k1 and f of k2, and they are of the opposite sign, which means their product is negative, that means they will contain one of the roots, and exactly one roots. Because if k2 has been there, then f of k1 and f of k1 both would have the same sign. Are you getting it? So these two conditions are always the necessary and the sufficient condition if I want to claim that exactly one root lies between k1 and k2. Are you understanding all of this? Can I move ahead from here? Now, let's solve one question so that we get more clarity on this part. It says number of integral values of k for which one root of this equation lies in the interval 1 to 2 and other root lies in the interval 2 to 3. How simply amazing this question is. First of all, look at the coefficient of x square, which is positive. So it is going to be an upward facing parabola. And they want its roots to be distinct because they want that one of the roots lies between an interval which is 1 to 2. So let's say 1 is here, 2 will be here, and the other root lies between 2 to 3. So if 2 is here, 3 should be here. Simple. The question is done. The question is done. Why? Because if I simply not even remember the concepts of location of roots, if I simply apply some standard decent logic, I'll say that, sir, first of all, I hope you can see f of 1 should be positive. Second of all, f of 2 should be negative. And third condition, I hope you're noticing, f of 3 should be positive. If I simply impose these three conditions and take their intersection, my answer will be there. F of 1 should be positive. F of 1 means 2 minus 8 plus k should be positive, and f of 2 should be negative. So 2 square is 4, 4 into 2 is 8, minus 8 into 2, that is 16, plus k should be negative. And f of 3 should be positive. 3 square is 9, 9 into 2 is 18, minus 8 into 3, 24, plus k should be positive. I'll simply take their intersections and that will be my final answer to this question. 2 minus 8 is 6, so k minus 6, of course, so k should be greater than 6. 8 minus 16, that is how much? I think minus 8, so k should be less than 8. Here, 18 minus 24, again minus 6, so k should be greater than 6. So if I take intersection, k greater than 6, k greater than 6, so they are same, k less than 8. So I'll say that k lies between 6 and 8. So any value of k if I take between 6 and 8, it will ensure that this equation has roots between 1 and 2 and 2 and 3. One root exactly between 1 and 2, other root exactly between 2 and 3. Now please understand, pay attention to this part where I am asked that number of integral values of k. So between 6 and 8, there is only one integer, which is 7. So how many integers lie between 6 and 8? 1, which is 7. My answer will be 1. Did you all get this part, or shall I re-explain this? All the participants. Was it again not an easy question, not a simple question? Can you not crack it within 10 to 20 seconds if you simply knew the logic? That's exactly what we are trying to make you understand, that if you are aware of these concepts, you can crack these questions within seconds. Second part, both the roots are confined between K1 and K2. So both the roots. So either you will have this case or this case where A is positive, this case when D is 0, this case when D is positive, or you can have this case where A is negative. So when A is negative, you have two choices, either D is 0 or D is greater than 0. Now I am told that K1 and K2 both contain alpha beta. So if this is K1, let's say, if this is K2, they contain both alpha and beta. I hope you're understanding it. If this is K1 and this is K2, they both contain alpha and beta. Everybody with me on this? Now pay attention to this part. I got to use that separator, that segregator here. Club those first two conditions which we have discussed about location of roots. I hope you do remember. A, f of k1 and f of k2 will have same sign, which means first of all I'll apply this. A of f of k1, A of f of k2 will be positive, because pay attention, A is negative, f of k1 negative, f of k2 negative. So A and f of k1 and f of k2 will have same sign, which means A of f of k1, A times f of k1 and A times f of k2 will be positive. Third condition, of course, roots are there, real, which means D will be either greater than or equal to 0. Fourth condition, this separator or segregator you got to use. If you don't use it, the chances are that K1 and K2 both could lie here, or K1 and K2 both could lie here. So I'll ensure that 1, which is K1, is less than minus b by 2a, and K2, that is greater than minus b by 2a. So K1 is on the left and K2 is on the right. That will be ensured by applying this third condition, and then I'll take the intersection. Are you getting all what I'm saying? Everybody with me on this? Now, the second condition, if K1 and K2 lie between the roots, again a simple one. So again, either this could be case or this could be case. If this is the case, here A is positive, D is positive. If this is the case, A is negative and D is still positive. Now I am told K1 and K2 lie between alpha and beta. So this is alpha and this is beta. They should be distinct. So K1 and K2 lie between them. Here this is alpha, this is beta, and K1 and K2 lie between them. Are you not realizing that if I am asking you f of K1 and f of K2, if I'm asking you f of K1 and f of K2, are you not simply noticing this part, that here also f of K1 and f of K2, they are exactly opposite in terms of sign of A. If A is positive, f of K1, f of K2 negative. If A is negative, f of K1, f of K2 is positive, which means what? Is it not necessary and sufficient that first of all D should be positive? Second and third condition, A times f of K1 should be negative, A times f of K2 should be negative. This is same as when we discussed that a value K lies between alpha and beta. That's exactly what we are doing, but this we are doing for two values, K1 and K2, which is same. Are you not understanding this part? Everyone comfortable with this? So with that, I think we have done a sufficient revision of quadratic expressions. We have revised this entire chapter, quadratic expressions, in a quicker manner, where we are trying to make you bridge your 11th with the 12th. So whatever concepts which were necessary and important from this chapter, we have made you try revising them, because in 12th you will be needing them. Identities, the important rules or the formulae, then quadratic expression, its maxima and minima, its graph, and then of course the location between roots, and then of course the fourth part, Newton's formula. This is very prominently asked or used in calculus, indefinite integration, area under the curve, differential equations, even in indefinite integration, AOD. A lot of places are there where you will keep using the learnings, the nuances, the minute details of this chapter, quadratic expressions. With that, I think you have gotten a decent clarity on this. Let's meet some other time in some other video. With that, thank you so much. You have been a great audience. Take a good care of yourself. Good night, everyone.